Hello and welcome to More Questions of Science, the show where we tackle your extra questions on everything from curing cancer to coping with climate change. Now, the original Questions of Science were recorded in front of a studio audience at the Francis Crick Institute in London. And if you haven't heard them, then I suggest you go back and listen to those, because this show is a chance to hear some of your feedback and further satisfy your curiosity, answer your questions. The episode we recorded on the future of fertility was a thought-provoking exploration of both the ethics and the science of everything from egg freezing to embryo models. But you were curious about a lot more. And today, two of the experts from that panel are back to answer more of your questions. Lucy van der Wiel is a senior lecturer at King's College London with a focus on reproductive technologies, and Dr. Güneş Taylor is a developmental biologist at the University of Edinburgh Centre for Reproductive Health. Thank you both for coming back. Now, one of the wonderful things about these bonus episodes is that we get to update listeners because science is moving on all the time. And so I want to start with an interesting development in the area of vitro gametogenesis, which is where eggs and sperm are created from skin cells. Now, when we discussed this in the studio, this had been done in mice. But Güneş, I'm right that since then a team in the US have done something similar in humans.
Yes, that's right. In vitro gametogenesis is the pursuit of trying to create eggs or sperm in a lab. And this recent report from America basically uses a really interesting approach, I think. They start in the same way that people did when they were making Dolly the sheep, where they take a skin cell and take the nucleus out of the skin cell and then transplant it into a donor egg that has had its own nucleus removed. And by introducing the skin cell into this human egg cell, the team were able to get that skin cell, which has twice the copies of DNA that a standard egg would have. They did these little tricks to get that skin cell nucleus to sort of register that it was in a human egg and to kind of spit out the extra sets of chromosomes that it had inside of it. And the exciting thing was they did find that they got admittedly a small percentage of fertilizable eggs, but nevertheless, they did manage to get some fertilizable eggs, which I think is pretty incredible.
Yeah, and we have an associated question actually from Anika Burley. She asked what the future might be like for this kind of technology, given that you can avoid risks associated with traditional egg retrieval. So her question was, do you think this technique will become the normal route for IVF? And if in theory anyone could take a sample of your tissue and create a baby, what do you think are the moral and ethical risks of developing these techniques?
So this particular technique that was recently published still relies on using donor eggs. So it doesn't bypass the issue of needing to collect eggs at all. Now, some of the work in mice has been about genuinely just taking skin cells and reprogramming them back to a stem cell state and then encouraging them down the road towards eggs and or sperm. It sounds really scary, like, oh, someone could just take a little scrape of your skin and next thing you know, you're a father or a mother, depending on what's going on. And it's really not as simple as that. It's also extremely labor intensive and not that high in its success rate, let's say, right? I think the recent report that came out was 6% maybe of the eggs they managed to get were fertilizable and proceeded. So do I think that this is going to be the standard approach going forward? Most probably not. However, do I think it's a fantastic technique to have in our armory to deal with different circumstances and people who have differing medical needs? Absolutely.
We've seen that particularly in the UK, being a donor, so maybe providing genetic material, even if you don't become the social parent, is extremely difficult to do, not just technologically, but there's very strict laws around it. So you would imagine that if this is reliant on the same kind of or similar infrastructures that are very tightly licensed and regulated, then even if it was to become easy and successful, it would be hard to do that. If it could be automated, if it could be much easier to do, then it would also be very different to regulate. We could also think of it maybe in the distant future. So if we think of the distant past and already the worries about paternity now also moving to maternity, we can also think about a distant future in which we could potentially change as a species. You know, we've been mammals who have reproduced through sexual reproduction. But now in the last, couple of decades, we've been able to do that in different ways with IVF, with insemination and so on. We don't necessarily need to do sex anymore the way it was done for millennia. But with this, we could become more like flowers or like squid, where we release a lot of reproductive material into potentially machines or infrastructures that could create a different kind of offspring, a different way of thinking about how we relate to the future, or what an embryo means if you don't just make a few, but you make a lot of them. So it is interesting to think about in a sort of creative way what could be possible, but at the same time to be realistic that at the moment those things are not available yet, and they may never be. It may never work out.
It's worth also saying this recent report about the human eggs being created in this particular way, effectively, that egg has half of the identical DNA as the parent. So it's not like a true egg where the DNA has kind of been shuffled up. We call that meiosis. It's a really critical part of making your germ cells, is shuffling your DNA so that, siblings are related, but they don't all look identical to each other or more similar to each other because they have this variance. And so this particular technique would result in a sort of effectively 50% clone of the parent from which the skin cell came, which is not necessarily ideal.
We have another question, actually, which is, so it's related to the previous question in the sense of regulation of emerging powerful technologies. It's a question about genetic testing. So last summer, the NHS announced it will sequence the whole genome of every newborn baby within the next decade, starting from this year in 2026. And Amana Wilkins wondered what ramifications this will have on the individual decision-making processes, particularly regarding future reproduction.
I mean, as a researcher with my researcher's hat on, that's really exciting in terms of resource building. We know increasingly that sort of health conditions and health propensities and health outcomes that we're interested in are not single gene issues, basically. And so having access to the whole genome is really powerful for us because it allows us to theoretically follow up these babies and then see in much greater resolution which parts of the genome are contributing to these kinds of health outcomes.
Because that's the key, isn't it? I suppose if it affects your decision making, you need a lot of information to understand how you should make decisions. So, Lucy.
Yes, and the information about your genome is always interpreted. It's always framed in a particular way by experts or by large language models or by websites or governments. I mean, obviously, these are babies, so they can't interpret it yet. But when they grow up, at what point in their future will they have access and how will they determine what that means? Will their parents have access? And I think there's a really important right not to know things. There's a really important right not to navigate the kind of risk information that comes with this kind of sequencing. So for a long time, we have been able to do DNA sequencing on a commercial basis, on a voluntary basis. But if it happens at a sort of population level, on the one hand, it's great to do scientific analysis, but on an individual level, you can wonder, there's ethical concerns about not being able to access it, but other people can. And, there's a lot of people who opt out of certain testing. For example, testing about propensity to cancer or to diabetes or to dementia. I mean, knowing that you have a certain risk factor, for example, might really affect how you live your life, what choices you make, and not everybody wants to have that. And I think this is also linked to the potential of whole genome sequencing at an embryonic level, which we now see being introduced in the US already. And so if we are normalizing whole genome sequencing of babies, is this also a step towards whole genome sequencing of embryos, which comes with a whole bunch of concerns about people potentially medicalizing reproduction. But there are also the questions about the level of responsibility, guilt, anxiety that intended parents may have around knowing this information and deciding which embryos to implant.
Just on that, actually, maybe we've got a very closely related question from Ezgi Kurt, specifically about artificial intelligence and how that feeds in to the sequencing of embryos in particular. The question was, with new pattern recognition models through machine learning, I've heard of some companies offering more advanced genetic testing by genome sequencing of embryos prior to insemination, which is what you mentioned there, Lucy. Do you think these technologies will become more widespread and increase elective IVF procedures? So, Güneş, because Lucy partially answered this.
I think the easy answer about the elective IVF is I think most people make that choice based on money now and also going forward into the future. Money's always going to be, I think, the biggest constraint or consideration when it comes to IVF. But to turn to the AI part, we're talking about a context where whole genomes are being sequenced, right? That's a vast amount of information, and that has to be coupled to all of the things that we have found out through research and science, basically, to sort of derive meaning. And that's a really big task, right? I think a really helpful analogy in this context might be something like if you go out to buy a product, say, whatever, a washing machine, a dryer, something like that, there are many different thousand types of these device out there. And if you imagine generating a spreadsheet in which, say, you have 100 different washing machines and you have, say, even 100 different parameters across which you have information for each one of them, right? Even that alone should strike anxiety into your heart as you try and make a decision about which one do I get, right? And it's kind of, it's a bit of a facetious example here, but it kind of captures this essence of, I think, of what do you do if you've paid a huge amount of money, you've generated all these embryos, you get given all of these different pieces of information. Well, this one might have a bit of a higher likelihood of having perfect pitch, or this one might be a little bit more sporty. But, how do you integrate all of that information, basically? That's the real problem. And there is a possibility for AI potentially to help with that. Though I'm sure Lucy would agree with me here, the issue with that is who programs this AI to give the specific values to each of these different parameters.
I think just to add to that, there's something really interesting here about the relation between cells and data. Because previously, reproductive technologies were really focused on cells, and they can be regulated much more easily. They're within a lab with people who've been trained, with licenses given out by governments and so on. But data moves much easier than cells. It can move between labs, it can move to other people's hands, it can move between countries very easily. So regulating that or controlling that is going to be a very different ballgame. And we've seen with cryopreservation technology that we can move cells more easily around the world. But now that these data regimes that are different in different jurisdictions may affect what happens with IVF across the world or other reproductive technologies, we are entering a new territory in that respect. But a bigger point here is that we already see that big tech and the fertility sector are integrating more and more in relation to IVG, which we discussed earlier, which is now also developed not only in universities, but within startups that are funded by venture capital, that are located in Silicon Valley. And that comes with its own ideologies of trying to scale up technologies, trying to disrupt the innovation without necessarily relying on a lot of regulation, and really working with a particular type of commercialized business model that's really focused on rapid growth. So I think that link between bringing in not only the technology, but the ideology of big tech into the fertility sector is something that we need to be really aware of. And I think this is one of the examples of that.
There was a story recently, wasn't there, in Denmark, which I think draws out this difference between the ethics of choice. As you said, Güneş, if you're at the level of saying, I want a child with perfect pitch or something like that, then it sounds almost, trivial choices you could make. But the Denmark case, very specific about a sperm donor who carried a genetic mutation that dramatically increased the risk of his offspring developing cancer. The donor, I think the statistics were, fathered almost 200 children, at least, perhaps more, several of whom had already died. So would this kind of sequencing, in that case, sequencing of embryos, prevent that kind of thing from happening, where the ethics would seem very clear if that were the case?
Yes, there is already some availability for screening of certain types of cancers. But of course, by having access to the whole genome, you can screen for more different types of cancer. And you can sort of lean more into research that says, oh, well, this particular non-coding variant slightly increases the chance of this type of cancer or whatever. But the starting point is generally just the DNA that you have between the two parents, right? And so the odds that you can find an embryo that doesn't have some propensity for some sort of medical issue is pretty much zero, right? It's going to become a question of which type of cancer do you want to allow your child to have the propensity for, because it's not going to be without. And that's where the paradox of choice thing comes in, right? Because then you think, well, you can imagine a future where people spend a vast amount of money to try and make the best choices that they can, and people will still get sick, right? You'll still have cancer. The health choices and the way you live your life is still going to result in negative health outcomes potentially.
I think also in terms of the Danish donor, it would have made sense to maybe do more genetic testing on him rather than the embryos. And a lot of testing does happen when people become donors to ensure that they are healthy enough, but apparently this wasn't tested for or slipped through. I think part of the issue here as well is that he has fathered, at least genetically, so many children. Because if this was an intended parent where this happened, this wouldn't actually be that remarkable. People often pass on some propensity for the cancer risk or genetic disorders. But because this is, on the one hand, one donor has an abnormal amount of children, and also because it's a donor, so his sperm was also a product that people bought with the understanding that it would be safe and that they weren't aware of this risk. And that puts it in a very different ethical and social frame. So I don't think whole genome sequencing of embryos would be the solution here, but maybe more stringent testing of donors, but particularly looking at the limitation of how many children can be fathered by one particular donor.
We have an interesting question now from Amanda Benson about where all these developments will lead in terms of surrogacy. And she wrote in to say, I've been a surrogate for a couple that couldn't have children. Will scientific development reduce the need for surrogates? Or is there a risk that they will only be used increasingly by richer people?
Surrogacy is a really interesting scientific problem, let's say. So there is a growing field called ectogenesis. It's the pursuit of creating sort of artificial wombs or artificial spaces in which embryos can be developed. There has been very interesting advances in that space. I think that it's been a little bit on the quiet side. I mean, it involves a lot of money to do that, and investment. There was a good amount of work done on something called the bio bag. I think that got a good amount of press coverage at the time, which is kind of like a bag that is full of different kinds of fluids that can help bring preterm birth, in this case it was sheep actually, sort of through that last stage of development successfully and allow them to be born. So that's more like, premature birth care. But there is also work being done increasingly at the other end of pregnancy, at the very sort of early stages, to try and model in the laboratory how embryos first implant into sort of uterine tissue and what does that interaction look like. And there is a hope in this sort of ectogenesis field that it's going to be possible to bridge those two different ends of pregnancy understanding to sort of create a pipeline in which you could theoretically develop an embryo from the very start all the way through to term. That's a sort of grand vision, but of course human bodies have evolved over millennia to be able to do this with very little consideration almost. And that's where surrogacy comes in, because that is a perfectly honed biological machine and incubator essentially. Yes, there is hope for science to add to that, but is it going to change the amount of surrogacy? I can't see that for a very long time.
I think one more thing to add about ectogenesis is that we often talk about it as artificial wombs, but the complication of it is that it also has to be an artificial placenta and to a degree an artificial whole woman's body, or at least someone with a womb. So it's not just a container, but pregnancy is an incredibly complex and amazing phenomena that some of us can do or embody. And there is a lot of interaction between the maternal body and the embryo or the fetus. So it may sound like, okay, we can just develop a container in which an embryo can grow. But really, we're trying to create a system that does all that interaction that happens between the embryonic body or the fetal body and the maternal body, and all the questions about nourishment and blood and so on.
Could I ask, is that just the way you describe it? Is it just an engineering problem in the sense that we understand those interactions fully? Or is it really that we don't fully understand it anyway? So we need to understand fundamentally what's happening before we can even begin to engineer a solution?
Yes, that's exactly right. We don't understand enough about it. It's a highly interactive process, very, very dynamic. And it's not just dynamic in any given moment, it's dynamic over the course of 9 months, right? The different parts do different things at different points in the developmental process. It's extremely complicated. So yes, I mean, you know, we all believe that once we have the knowledge, then it is just a matter of engineering. But we are a long way away from actually having all of the knowledge to even be able to face the technological challenge, as it were.
And that's also why, you know, it's even hard to gather that knowledge because scientists are only allowed to culture and research embryos up to 14 days. So kind of by regulatory definition, they can't know exactly what happens on day 15, 16, and so on. And of course, then you would be studying the embryos outside of the human body. So what kind of matrix you would have to create in order to keep that growing much longer, to maybe a month or 2 months and so on, you know, at the moment legally cannot be researched. So even if it was technologically possible, at least in the UK and in most countries, you can't legally do that.
Well, let's turn now to a different area, but we had a lot of emails about it, which is declining fertility rates and what might be causing them. So Molly James asked, is the rise of ultra-processed foods and microplastics in modern diets having a measurable effect on fertility? Güneş.
Right, so this is not my specific area of expertise, but my understanding of that literature is that there is a declining sperm count in many Western democracies. I believe the number is something like a 50% reduction in high quality sperm production since the 1970s. It's something like that. So there is a measurable decline that is occurring. To the specific point about ultra-processed foods and microplastics, there's a lot of correlative data. So we know that there are more microplastics in the environment, and there are plenty of studies that report microplastics in all kinds, or increasing microplastics in all kinds of human reproductive systems. The placenta that we've just been talking about, this really critical interface between baby and mother, the latest studies have shown that there's huge numbers of microplastics within placentas, which is terrifying. There's studies to show that some of the best ways to offload the microplastics and ultra long-lasting molecules that accumulate within our bodies is to breastfeed, for example. So you can offload these sorts of chemicals into your offspring, which is another terrifying statement. To the point about ultra-processed foods, we know that males that consume large volumes of this type of food have significantly reduced sperm quality. Now, I said at the start of this that it's a correlation. The direct mechanism of how this might occur is not known. But looking beyond humans, we know that the chemicals and endocrine disruptors that are found in the environment of most organisms will impact and does impact significantly their reproductive outcomes and their development. And so we are humans, and therefore we are part of that same sort of broader framework. And so, you know, to believe that we wouldn't be impacted by that would be ridiculous. I think the positive message around this that needs to be said is, especially for sperm, what's amazing actually is it takes about 3 months to create sperm from scratch, from the stem cells in the testis. And so actually for males, there's very robust evidence to show that if you sort of clean up your act, you know, reducing heat exposure, reducing exposure to plastics and the chemicals that leach out of plastics through water bottles and pre-prepared foods, reduce the alcohol, reduce the saturated fat for 3 months or so, you can really substantially change the quality of your sperm.
Well, we've just got time for one more question, which is, I think, a wonderful general question from Mez Hakim, who is a medical student. And the question is, as a medical student, what do you think our future doctors should know when going into the field of fertility? And how can we help both women and men have better healthcare overall? So that's a big question. But I think that question about what a future doctor should know going into the field is a really wonderful question.
That's a wonderful question by Mez, and I hope that Mez does take the decision to go into this field, because I think it's a very exciting field to work in for many different directions. We do see some changes happening at the moment. So in many countries across the world, we are seeing cuts being made to academia. And academia is traditionally the place where people get trained for these kinds of specializations. So public funding, both for academic research and for training, has decreased. And that has an effect on new people coming in the field, because they are now more often trained in, say, a private equity-backed private clinic rather than in a university clinic. And there are very great private clinics, also private equity-backed clinics. So it's great that they exist as well. But the research is often reflecting a particular economic model that looks at what can be commercially interesting for the clinic or what can be relevant in terms of research in the next 3 to 5 years, rather than fundamental research that doesn't directly have a clinical application and so on. So I think it's really good if young people and if medical students like Mez have an opportunity to experience academic freedom, to experience clinical practice that is free to an extent as well. So I think young people should be, in a way, activists about their work. They should think about, who do I want to serve? What do I want to research? What do I want to bring into the world? And, how is my work not only about creating embryos and potentially live births, but also about creating a medical system and a society in which we have equality and justice, but also in which we really have power in the hands of people more than only in economic interests.
Yeah, I mean, I couldn't agree more with that. And I think it's just a sort of increasing the baseline mindfulness, let's say, around future fertility, right? It's just to remind all of the med students as they go through, most of the patients that you'll be treating who haven't not yet reproduced are probably not going to for a long period of time. So many of us spend so long trying to avoid pregnancy during our younger years. You get the absolute fear put in you that if you look at someone of the opposite sex for too long, you might get pregnant, that people just assume that it's going to happen automatically. And that's not necessarily the case. And so just a bit of awareness about that, and good general practice about looking after yourself is probably the best thing that you can do, to be honest. But also fund more research.
Couldn't agree more. I think that's a wonderful note to end on. Thank you very much. Thank you, Güneş Taylor and Lucy van der Wiel. And thank you to everybody for listening. Join us again next week for another More Questions of Science.